Hi students, in this video we are going to learn about equation of the plane passing through 3 points. Already we learned how to write equation of a plane it passes through 1 point means, because we will apply the same concept here. Equation of the plane passing through 1 point means the equation is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. We will apply this concept to find the equation of the plane passing through 3 points. Now consider a plane which passes through 3 non-collinear points x1 y1 z1, x2 y2 z2 and x3 y3 z3. Let a, b, c be the direction ratios of the plane. Here we are given 3 points and the direction ratios of the plane. Now we need to find out the equation of the plane. We already learnt that what is the equation of the plane if it passes through 1 point. If the plane passes through these 3 points, we will take up this point, we will write the 1 point form of the plane equation, that is it passes through this x1 y1 z1 means what is the equation for it. If equation of the plane can be written as a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Since the plane passes through x1 y1 z1, we are writing this 1 point form. If these 2 points lie on the same plane means definitely these 2 coordinates must satisfy the plane equation. In place of x we can substitute x2, in place of y we can substitute y2, in place of z we can substitute z2. So it can be, the plane equation can be written like this. And the plane passes through x3 y3 z3 also, hence it will satisfy this 1 point form equation. Hence in place of x we can write x3, in place of y we can write y3, in place of z we can write z3. So we got 3 equations. Using this we need to find out a, b, c. So what we do is we are just we are going to write cross multiplication concept using the second and third equation. When we write it under a, you know that only these two these coefficients should not be written. B and C coefficients should be written. You know how to do it. So we have just written it, and we assume that that value is equal to k. And when we do further simplification, we will get this expression: determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. Hence this is the form we will use to find, this is the formula we will use to find the equation of the plane passing through 3 points. I hope you can easily memorize this formula. Now we can solve problems related to it. Now the first question is find the equation of the plane passing through the points a, b, c. Here it is the direct application of this formula. In place of x1 we will substitute values of x1 y1 z1 and x2 y2. When we find out the determinant value is equal to 0, when we simplify it we get the final answer is minus 18x plus 10y minus 15z minus 19 equal to 0. I hope you can understand this problem. It is the very easy problem. Now we move on to next question. In the next question, the question is from the point P, A, B, C, perpendicular PL and PM are drawn to YZ plane and ZX plane respectively. Find the equation of the plane which passes through OLM. Now we need to write the equation of the plane which passes through 3 different points: origin, L and M. We know the coordinates of origin, but we need to find out the coordinates of L and M, and then we can solve this problem. If you observe that the PL are drawn to YZ plane, in YZ plane x value will be 0 and which is perpendicular. Actually from the point P, A, B, C, perpendicular PL is drawn to YZ means from point P in the space we are drawing perpendicular to YZ plane means y coordinate value will be 0 and the remaining values B and C will be the y coordinate value and Z coordinate value. and then we are drawing perpendicular line from P to ZX plane. In ZX plane we know that y coordinate value is 0, and since we are drawing from point P to ZX plane, its coordinate will be the meeting point, that is PM. The coordinate of M will be y coordinate value will be 0 and x coordinate value will be a, and z coordinate value will be 6. See, that is what is written. Coordinates of the point L and M are L 0, B, C, because L lies on, as you know, YZ plane. So YZ plane x coordinate value is 0. Since we are drawing from P to L perpendicular line, the coordinates of coordinates of point B, y coordinate and z coordinate will be same for this L, and then M, we already know the coordinates of origin. Using these 3 points we will find the equation of the plane. We will apply the formula here, and when we simplify it we are getting this answer. I hope you can understand this. Now we move on to next question. Show that the points, these 4 points are coplanar. Also find the plane containing them. Here we are given 4 points, and those 4 points are coplanar. Coplanar means those 4 points lie on the same plane, and also we need to find the plane equation. Here all these 4 points are coplanar, means we can take any 3 coordinates through which the plane passes. Hence we can use 3-point form to find out the plane equation. After finding the plane equation, if the 4th point's coordinates satisfies the plane equation, means we can say that it is a coplanar, and then we can write the plane equation as well. So we are just taking any 3. We are taking this A, B, C points. For that we are using this plane equation, 3-point plane equation. When we simplify it, we are getting this plane equation. After that, if this equation is satisfied by the remaining coordinates of the point, then we can say that all the 4 points are coplanar. When we substitute the coordinate value, x value, y value, z value in the plane equation, it satisfies. Hence these 4 points are coplanar, and also we have written the plane equation. I hope you understand this concept. It is a very easy concept. So with this I am completing the video. Thank you students. Thanks for your cooperation.